Hey, good morning, everybody. Thank you so much for joining us here. Super excited to be here. As maybe some of you know, I know there's definitely some returning faces to HashiDays. We're doing it a little bit different than maybe we've done it last few years. Last year we did 3 cities, but all on the same day. And I think what we learned was it made it difficult to be in all 3 places at the same time. So we're doing it slightly different this year. We started the roadshow in London earlier this week. Obviously, we're here today in Munich, and then we'll take it to Sydney middle of next week. So appreciate all of you joining us here today in person, and great to see all of the ambassadors as well. So maybe just to start us off, I think one of the big announcements over the last month, many of you probably saw this. I think we saw an incredible amount of commentary on social media, was we announced our intent to be acquired by IBM. We're incredibly excited about this next phase and what it means for the community, for our customers, for our partners. I think ultimately what it's going to allow us to do is continue to invest in making the HashiCorp community much bigger, much better, and really focus on supporting our users and customers at a different size and scale. Today we operate in about 30 countries. IBM operates in about 175 countries globally. So it really allows us to sort of bring a much different sort of audience and a bigger scale with the HashiCorp portfolio behind it. At the same time, I think there's a lot of great synergy between the portfolios. Many of you, and you'll see some talks later today, use our tools alongside OpenShift, alongside Ansible, alongside tools like Turbonomic and Apptio. So I think when we look across the portfolios around automation tooling, around data management, around cloud, there's a lot of interesting synergy where they complement each other. And I think this is an opportunity for us to bring those solutions together and have them work better together. So you'll hear a lot more from us in the coming months after the deal closes, and we can really start to get deeper into talking about some of those integrations. But we're super excited about what it's going to allow us to do and take the kind of the products and the community to another level. So with that, I want to start by sort of framing a little bit, some of the learning we've gone through over the past few years in terms of organizations really thinking about how do they industrialize cloud, how do they do it and standardize at scale. And what are those common patterns? And I think what we've seen over and over is sort of a convergence into thinking about a number of different key life cycles. One is around application life cycle. So when we think about how do we go from having every team have their own version control system and their own CI/CD, and we have 1,000 Jenkins in the environment, to really driving some level of standardization around, okay, we're going to use GitHub, or we're going to use GitLab, or Azure DevOps, and really have a consistent way in which we're managing the application lifecycle of writing code, collaborating, testing, having a consistent set of pipelines. From that then becomes the set of infrastructure lifecycle, right? I think where a lot of people started with cloud was, free-for-all. Some teams are on CloudFormation, some teams are using Bicep, some teams are using Terraform. And then realizing at scale that becomes super challenging. How do we have a consistent way across a multi-cloud estate of managing the lifecycle, right? Creating shared reusable modules, common pipelines, common governance. So this really becomes around the infrastructure lifecycle. I think we see the same thing around security, right? Whether we're doing key management, secret management, data protection, how are we doing that in a common way? And then ultimately it becomes the monitoring challenge, right? Whether I'm using Datadog or New Relic or other tools, it's how do I have a common way that I'm monitoring all these things? And so I think this is what we've seen over the past few years is that really in each of these categories, platform groups are trying to drive a set of standards, right? For us, obviously with HashiCorp, we're very much focused on those middle two, infrastructure and security. And what we found is that most organizations still struggle to really do it correctly, right? And so I think what we've heard, and you've sort of saw us maybe relaunch some of our messaging and marketing over the last few months, was this ask to say, hey, can HashiCorp be more prescriptive about what's the right way to do infrastructure lifecycle? What's the right way to do security lifecycle? We have the fortunate opportunity to work with thousands of enterprise customers on their journey to cloud. And so we've sort of seen, I'll call it the good, bad, and ugly of how to do cloud adoption. And so for us, this notion of the infrastructure cloud is us trying to now make the switch into being a little bit more prescriptive, providing almost opinionated guidance of saying, here's how we think infrastructure should be done right. Here's how we think you should do security. And how we want to deliver this ultimately is in sort of as a service through the HashiCorp Cloud Platform. So you'll see a big focus on the HashiCorp Cloud Platform as we're trying to, A, remove the burden of operating some of this stuff, B, be more opinionated about how things like infrastructure and security should be managed, and then C, drive tighter integration across our portfolio. I think, in the early days, it used to be we had 8, 9 different products, and they were sort of separate Lego pieces that users kind of assembled. But I think a lot of users said, okay, well, why should we have to have the burden of integrating Packer and Terraform? You guys, HashiCorp, know how they're meant to be used together. Why don't you do those integrations for us? So that's what you're going to see more and more of from us. We call this sort of the broader infrastructure cloud, and it's really about helping our users and our customers do cloud in a way that's easier, right? Ultimately, our goal, when I sort of think about it, is you have these two different audiences. You have your platform teams and cloud centers of excellence, DevOps engineering teams, etc., who our job is we're really defining how does this platform work. We're defining the blueprints, the templates, how we want it to operate in Azure, Google, AWS, on-prem, etc. And then we have our application teams that really what they just want is a consistent way to consume cloud. Most of the time, the application teams, they're building a Java application. They want a Mongo database. They don't actually really care how does it work, right? They just want a simple experience that lets them focus on the things they care about. And that's really our goal. So with that, I want to sort of jump into some of the actual product updates here. We're going to start off talking about infrastructure lifecycle management. And again, this is sort of that classic cycle of building, deploying, managing, right? And when we talk about sort of lifecycle, I think what's key to sort of frame here is we think about it through sort of what's a day 0 versus day 1 versus day 2 problem. And what do I mean by that? A great example of this is if we take Packer, right? So when we take something like the Packer tool, a day 0 problem is, hey, I need to create an AWS AMI, for example. I'm building a VM image. That's a day 0 problem because I got to create the AMI first before I can provision the EC2 instance with it. So I kind of need that as a prerequisite. It's the first thing I do. And so most people start with Packer to do exactly that, right? They're building an image and it's a one-off, and now I have an AMI ID, and I probably hard code that AMI ID into my Terraform configuration. But then you start to get into a day 1 problem where you realize, okay, I have 50 app teams or 100 app teams or 1,000 app teams, depending on the size of your organization. How do I share that image with everyone? Do I just hard code an AMI and email it to 1,000 teams and say, please use this? And then every week when there's an update, I email them again? It becomes impractical. So you start to realize, okay, I actually need a registry, a common way that I'm publishing these images so that my whole organization can discover them. I need ways of versioning them because I'm pushing new versions. And then over time, you start to get into some of these day 2 operating challenges with things like, okay, I discovered a vulnerability, right? There's an OpenSSL vulnerability. There's a Linux kernel CVE. And now this image has a well-known issue. How do I revoke it across hundreds or thousands of environments where it's been deployed? So it becomes around that day 2 challenge of, great, I want a revocation workflow that could integrate to Terraform to say, hey, these 500 environments have an out-of-date image, right? So that really becomes, when we talk about lifecycle, it's that whole process of thinking about, I'm not just creating the image day 1, I have to publish it, I have to share it, I have to version it, I have to get rid of it over time. That's the lifecycle management challenge. And so this is why we built HCP Packer. So one of the big updates we're introducing for HCP Packer is this notion of webhooks, right? So people start using HCP Packer as this registry. They're sharing these images across their organization. But then the challenge becomes, okay, how do I integrate it with downstream systems, right? I published a new version, but how do I let people know? Or how do I trigger automation, based on that, a new image was promoted or I revoked it, etc. So what the webhooks allow you to do is tie into a bunch of these events. An image got published, you assigned it to a channel, you revoked it, etc. All those trigger events. And then we can use that to send notifications to human users. We could trigger automated runs with Terraform. We could automatically provision or deprovision images if they're no longer should be used. So it allows us to connect Packer into much more of our downstream automation. So let's take a quick look at what this actually looks like. So if we're logging into HCP Packer, we're going to click into a particular image here. And so here we can see we got multiple versions. We have version 13. So we're going to pick one of the older versions here, and we're going to revoke it. So it might be that this had a known vulnerability or it's no longer supported, etc. So we're going to say, great, this version no longer valid, do a revoke. And here we can see it's going to pop into Slack, and we got a real-time notification saying, great, version 5 was just revoked. Right? So you can start to see in a large organization, great, if I have hundreds of users of this image, how do I actually start to notify them in an automated way? One could be I'm sending Slacks and emails, but then even better would be I connect it into Terraform to help trigger a plan to say, hey, you need to update your environment. You're running on top of an out-of-date image. The next feature I want to highlight within Packer is what we are calling enhanced metadata visibility, right? And so the key here is if we start to think about we're building all these images, those things have a bunch of associated metadata. What was the Git version in that pipeline, right? What was the configuration of the Packer file? What were the inputs in my Ansible configuration? What were the things on that image that we installed? There's a bunch of valuable metadata when we think about the supply chain of building and managing these images. So in this case, we're going to click into an image here. Again, we see version 13 is the latest. And now what we'll see is a set of metadata, right? So what was the Packer version and then the Amazon builder? In this case, we're building an AMI. What was the specific version of that we used? This is the foundation that then we're going to build upon to start to automatically pull in things like metadata from your CI/CD environment. So if you're running you're running Packer inside GitHub Action, for example, we can automatically annotate what's the Git commit and what's the actual IDs of that pipeline. So then you can go back and say, hey, I want to understand what this thing built. What was the version of all the inputs to it, right? Over time, then we want to enable integrations with partner ecosystem as well as natively to be able to fingerprint what's running in a Packer image. So I can actually say it's this version of the Linux kernel, it's this package version, and that metadata then enables those revocation workflows that we saw. Now, one of the most common integrations is to use Packer to actually create Vagrant images. I'm curious, maybe show of hands, how many people ever used Vagrant? Okay, these are some OG HashiCorp users here. Love it. So Vagrant sort of, in some sense where HashiCorp started goes all the way back to 2009. And I think the moment we created Vagrant, the first challenge with Vagrant was, great, but how do I actually build the boxes, right? Like, how do I build and share Vagrant boxes for my developer teams? So one of the earliest cloud properties HashiCorp built was Vagrant Cloud. This was originally launched way back in 2014. As you can tell now, it doesn't really look like any of the rest of the HashiCorp properties. It has a very, vintage HashiCorp feel, if we want to call it that. But it still gets a ton of usage from the Vagrant community. And so we sort of looked at Vagrant Cloud and said, okay, can we modernize it and kind of bring it into the rest of the HashiCorp ecosystem? So we're super excited to introduce HCP Vagrant. This is basically taking the same capabilities of Vagrant Cloud, box hosting, private boxes, box search, publishing, all of that, and bringing it into the HCP environment, along with a new logo after about 10 years to make it consistent with the rest of the HashiCorp tools. So it has very much similar look and feel, similar capabilities, but now is within the HCP platform. So now it can actually drive a tighter set of integrations with tools like HCP Packer because they sit in the same platform, same login, same set of identity. So now I can use Packer and publish images and have those go into the Vagrant catalog in a more automated way. So this is part of our effort to sort of bring everything together. Now, I think the other property that we have that still, historically was on the outside of HCP was Terraform Cloud. Terraform Cloud was actually built before we had the HashiCorp Cloud platform. So it had its own identity, its own user interface, its own sort of experience that was separate from HCP. And over time, if you've been a user of both, you've seen that they've slowly gotten more similar. They start to look more similar, operate more similar. And so now we're sort of taking that to the next step by actually renaming Terraform Cloud to HCP Terraform and bringing it officially in. So this will mean it'll all be a part of the same platform. So effectively now with Vagrant Cloud and Terraform Cloud having now moved in, everything now sits within the HashiCorp Cloud platform. So our goal here, and this goes back to the beginning, is as we think about using these tools together, we want to bring them all into one platform so that we can do that integration cross-product. A lot of people use Packer to build an image that gets used in Vagrant. They use a Packer AMI that gets deployed with Terraform. So we want to enable those kind of cross-product workflows, and by putting them all in one platform, we make it a lot easier. You have one login, we can do service principals, you can have sort of a common IAM permissioning. So you can say, great, I can go from this Packer image and see in what workspaces it's deployed and then trigger updates across the whole thing. So that's kind of the intent here. Now, I think one of the questions, one of the sort of feedback items we often get, particularly in Europe, is that's great, but the HCP platform runs in the US. So, what if we need data residency? What if we need, stronger controls over where the data sits? So I'm super excited to actually announce an HCP Europe region. So the goal here is exactly the kind of concerns that we've heard for a long time. It's to solve around those data residency requirements as well as latency from not having to traverse to the US regions. So we're going to bring a separate HCP EU region. The intent is that it fully runs basically within the Dublin and Frankfurt regions for failover. And so the goal is basically all of the services over time will be available either in HCP US or EU. So when you log into your account, you can basically say, what region do I want to be in? And then you can consume your set of services much like you would with a cloud provider right? So the first service that we'll be bringing to EU will be HCP Terraform. That's now in limited availability. So if you're interested, please chat with us. But we're super excited about this. And you'll see Vault and other services coming in over time as well. So the next sort of challenge I think that we've historically heard with something like an HCP Terraform has been great, but what if I'm running resources in my private data center, right? If I have my own version control, or if I'm running Sentinel policy that need to talk to an internal system. I think a lot of users have historically used Terraform Enterprise where they can run it in their own data center to solve for that. So one of the things we're enhancing is the Terraform agent. The Terraform agent allows it to connect up to HCP Terraform, but then act as a bridge to things that are running in the local network. So historically, the Terraform agent was only used to run Terraform within your network, so it could talk to, for example, a vSphere or a networking provider or something else. But now you can actually use this to broker access to your version control system. It can run Sentinel checks. It can run webhooks within the private network. So it makes it a lot easier to use HCP Terraform, even if you have a private data center with private resources. The other sort of challenge we've seen is from customers to say, great, if I have hundreds or thousands, or in some cases tens of thousands of workspaces, it can be hard sometimes to really understand what's the whole state of my infrastructure like. Where do I have drift? Where am I failing policies? Where do I have an out-of-date version of Terraform? Where am I using an old Java module that I've updated, right? And so we built the Terraform Explorer to really make this a lot simpler. This allows you to query and interact with your whole estate. And so now with the Explorer, we've brought a bunch of enhancements to that where you can create custom reports and filters. So you can say, great, I want to see all of my workspaces in a production region that have drift or have an old version of Terraform. It makes it a lot easier to drill down when you have thousands of workspaces to really understand, okay, these are the 50 workspaces I need to go update the version of Terraform in. So this is a new set of UIs, ability to create a set of saved searches, as well as then a richer API to be able to programmatically query these out and then drive automation against them. So here you can see, for example, we got a little bit cut off here, but you can basically create a report and filter down to some of these different things. The next one I'm super excited about is the AWS Cloud Control, or AWS CC Terraform provider. This has been probably 2.5 years in the works, and I think one of the most common requests we always get is, great, the cloud providers launched a new service or a new feature or a new flag on a resource. What's the time lag between when that launch happens and when Terraform supports that capability, right? And this time has gotten faster and faster over the years. Often we're at AWS reInvent, with 0-day support with Amazon on stage. But there's a long tail of services where sometimes it takes a few weeks or a month or more to get access to some of those capabilities. And for a lot of Terraform users, that means it's unavailable to them. They can't use it. So one of the projects we started with Amazon 2.5 years ago was to say, is there a different way to do this where the provider integration could be automatic, right? Where the moment you launch it, it's just available, day zero. And so we worked with them on basically having exactly that, a specification-based approach that auto-generates the SDK, auto-generates the provider, auto-generates the documentation. So the moment they launch a new feature, we can basically hit recompile and have support for everything needed, right? It took about 2.5 years to work through all of those auto-generations, all the various bugs, all the various edge cases, but I'm excited that the AWS CC provider is now generally available, right? It now supports, I think 95% of the services within AWS, working to get to 100% by the end of the year, and the goal is that it has real-time support. The moment new capabilities come out, it's available in the CC provider. Now, just to be super clear, this doesn't mean that the existing AWS provider goes away. That's going to still be around. The main difference between the two is that, when you use the AWS provider, there's a human who's been thinking about how should this resource be used? How do we model it? What's the relationship between these things? So we can put a lot more focus into the ergonomics of it, if you will, right? The usability, how the resources relate to each other. The downside is because someone's sitting there thinking about it, modeling it, making it work in a really nice way, it takes time. So the goal is that these things coexist, right? You can use the CC provider to get real-time support for everything the moment a new service is available. And then the AWS provider exists providing almost a higher level, a bit more syntactic sugar, if you will, to provide a higher level experience over it. So these things will coexist. I'm excited that even in the period of beta that AWS CC has been out, it's already at over 7 million downloads and accelerating when you think about just 3 million of it in the last few months. And so I think now that this is generally available, this becomes another great toolkit for AWS users. Now, all of this is part of a broader announcement we announced with AWS in the last day or two here that we have launched a strategic collaboration agreement with Amazon. Amazon announces strategic collaboration agreements with a handful of their biggest, most important partners. And to me, it's a great testament to all the work we've done with AWS over the last decade, right? We spent a lot of time with them co-engineering Terraform and Packer and Vault and Consul and Nomad to make sure all of our products really work well within the Amazon ecosystem. And more over the last few years, really spending time with them, selling together and supporting our mutual customers and going a lot deeper into how do we make customers successful with Terraform landing zones, Sentinel policy as code, opinionated frameworks, well-architected guides. And so this announcement is really us about deepening that relationship. There's a lot more we're going to be doing on opinionated modules and landing zones and building out a shared policy as code library. So a lot more great things to come, but really a part of us really saying how do we go deeper and make this a more opinionated, easier to use cloud experience for our customers. Now, shifting back to Terraform Core, one of the features I'm really excited about is provider-defined functions. Some of you may already have played with this, seen it, but to show you kind of a little bit of a before and after, we can take a very simplistic example, which is, maybe you were provisioning an RDS database and you needed to parse out from that the region that it was running in. Now, Amazon returns these well-structured ARNs, but they're kind of fussy to work with. So one of the workarounds has been people created data sources. They aren't real data sources. They're basically function calls where they were passing in an ARN and then parsing that out to be able to pull out things like the region. Now, this works and allows you to sort of basically bring in some more capability into Terraform and almost a side effect-free function, but it's making this configuration more complex than it needs to be, right? It's introducing a data source that you don't really need. It makes it more verbose, when really what you wanted was just a function that could parse out that ARN. So now with provider-defined functions, that's exactly what you can do. In this case, you can see that AWS provider is exporting a function called ARN parse, and we're just passing in a variable, calling a function like we would in a programming language, and then pulling the region out of it. So when you compare these things side by side, you can see that it removes a bunch of this boilerplate and these sort of unnecessary data sources that weren't really doing anything, and allows you to do a much richer set of exposed capability by bringing these functions in, right? So this is just one simple example. There's a lot of things where people have wanted utility functions, and now we're seeing people start to build on top of this to build utility providers that export a rich set of functions for time manipulation, date stamp manipulation, templating, all sorts of things, because now you can basically bring whatever custom function you want that you implement in Go within a provider. Right? So super excited about this. Makes the HCL language that much more flexible. Now, one of the products that we launched a few years ago was HCP Waypoint. We launched Waypoint probably back in 2020, and originally it was really more of a CI/CD tool. And I think we spent the first few years building this and realized we didn't get it quite right. I think the feedback from users and customers was, we like the idea of Waypoint, but we have enough CI/CD tools in our ecosystem. We don't need any more CI/CD tools. What we really need is a higher level abstraction over tools like Terraform to make it easier for users who don't want to have to learn the details of a cloud provider, don't want to have to write HCL, don't want to have to maintain infrastructure as code pipelines. So we sort of reset Waypoint and kind of reimagined it last year. We said, okay, we'll go back to the drawing board. Really, I think what people want is almost an internal developer platform that's sort of abstracting away some of the complexity of cloud infrastructure. So the old version of Waypoint, we sort of archived, we relaunched HCP Waypoint at HashiConf last year, and we introduced this notion of what we called golden patterns. So the idea is our platform teams, we want to define these Terraform modules that might say, how do I define a Java app running in AWS or Azure or Google? But then my developer, my app engineer, they don't really care about the details. They want to come in and say, I'm defining a new application. I want to use a template that says, great, it's a Java app running in Google. And then they don't have to touch Terraform. They don't write infrastructure as code. They don't have to know the nuances of how the pipeline works. They sort of think about it at a high-level application, and they're abstracted from the detail, right? One of the things we found that was missing with this pure golden pattern, though, was, well, what about day two operations, right? It's great. You spun up my Java application, but now how do I build a new version? How do I deploy that thing? Something went wrong and I need to restart the process. My deploy was bad. I need to do a rollback. There's a bunch of day two operating actions that your application teams need that aren't handled by just having a pattern that deploys the application. What was missing was a set of golden workflows. So the piece I'm super excited about is now what we're enhancing Waypoint with is what we call actions. This allows a platform team to define a set of these day two workflows. How does a build work? How does a deploy work? How does a rollback work? But the developers don't have to know how it works. They're just using Waypoint and they're triggering that action. So they might run a build action that then is triggering a GitHub action that's actually doing the build of their application, but they don't need to know how that works. Platform team controls it. So if we want to move from GitHub actions to Jenkins or Jenkins to a Lambda function or whatever, we can change how the workflow works without breaking what the user is doing, right? They're going into a high-level, simple interface. So I want to make this real. Let's take a look at what does this actually look like. So we'll start with templates to create the application itself. So we're going to go into Waypoint here first. We're going to start by creating a new application. So we don't have any created yet. So we're going to start, pick from one of our templates. In this case, we'll say it's a Java application running on ECS. And then we have a few inputs that we can sort of make configurable. So in this case, maybe we say how many count of your instances do you want? And that was the only input. The user didn't actually have to touch Terraform, but you can see in the corner that Terraform run succeeded and it's linking us to the actual workspace and the run. So the user can now connect to their application and see, great, my Spring application is running. I didn't have to write Terraform. Under the hood, it's all infrastructure as code. It's managed as Terraform. All of our policies apply. All of that kind of good stuff is still there, but the developer doesn't have to care about it. Now, for most developers, it's not just a Java application. I have a Mongo database I need a Redis, I need a blob store. I have these other add-ons, if you will, to the application. So now I can come in and say, great, for my same app, maybe I want to add Redis to this. I don't actually have to care how does it work. I can basically install it. In this case, there's default set of instances, so I don't need to even provide any input to it. And we can see that, again, underneath the hood, Terraform is running. There's a link to the workspace where it was created, but the developer didn't have to think about it. Right? We, as the platform team, modeled it, wrote the module for them. All they get is their outputs and say, great, here's how you actually connect to it and use it. You don't have to think about how it's working. Right? So now let's say we need to actually do things with this application. Right now we want to update it. Great, we've deployed version 1. Now we have an update that we want for this application. How do I actually trigger that? So now you can see this little drop down with actions that can be defined. In this case, we're just going to update the ECS application, so redeploy it with a new version. Right? And so behind the hood, we've modeled this as a set of GitHub actions that are running the actual build and deploy process. The user doesn't have to care. They can see, great, run succeeded. If they want to drill in, they can. And we can see, if you didn't blink, that the application was updated, right? So it really starts to showcase what we're trying to get to with Waypoint, which is this becomes the internal developer portal, right? As a developer, I'm sort of thinking about what I care about at an app level. What's my template? What are my add-ons? What's the action and lifecycle I'm managing? And over time, make this a developer-focused experience, while then enabling our platform engineers to control how is this working under the hood, right? So the key is really to create that clean separation of concerns between the application's lifecycle and the infrastructure lifecycle. That's what our platform teams care about fundamentally, right? So I think one of the fun things for us is, obviously, we're very much an infrastructure company. We spend a lot of our time thinking about those infrastructure pieces. At the end of the day, these apps are still running on top of a runtime. That example was ECS. The runtime we spend a lot of time thinking about is obviously systems like Nomad and Consul. And so for us, we obviously are deeply invested in both of these things, and we're continuing to think about them as really bringing them closer together. I think what we've learned is, although they are built as sort of separate products, most of our users really run Nomad and Consul in close conjunction. Nomad is running, the deployment and scheduling and provisioning side of it. Consul is providing the service discovery and network automation. And so there's been a few gaps where Consul got ahead in features that Nomad didn't support. With the latest version of Nomad, we've kind of closed that gap. So now it has support for transparent proxying if you're using service mesh, API gateways, admin partitions. All of the latest and greatest Consul features are now available in Nomad as well. At the same time, we're continuing to make the scheduler have more capabilities. So now it has advanced capabilities around time-based execution. We'll show that in a second. So now you can get a lot more sophisticated and bring even more logic into the Nomad job scheduler, so you don't have to build layers of management around Nomad, right, to start and stop jobs in different ways. And then we're going to talk about long-term support, but we're bringing long-term supportability to both Nomad and Consul. So take a quick look at these time-based executions. We have a simple job specification here for Nomad. This is sort of highlighting a high-frequency trading app, for example. It might need to be only running during market trading hours. So here we can actually specify, great, Monday to Friday, start this application at 9:30 in the morning when the market's open, and then at 4 o'clock when markets close, automatically shut down the application, right? So this takes a whole bunch of logic that used to sit on the outside for a lot of customers where they're like, great, I need to run this job only at midnight for 2 hours and then turn it off, or in the middle of the day, or at certain things. People had to build a bunch of scripting around Nomad to submit it and then unsubmit it, do the job starts, handle restarts. Now you actually can just put all of that into Nomad. You just put it in the job spec, Nomad apply, and then you're off to the races. Nomad will handle the scheduling and failover automatically, right? So it's really about focus on making the platform more sophisticated, simpler to use, and reducing the burden as you think about running complex infrastructure. So maybe just to quickly highlight some of the announcements in the infrastructure category, there's the Amazon Cloud Control Provider, making it generally available, reducing that feature gap from new capabilities to availability in Terraform. It's bringing Vagrant Cloud into HCP with HCP Vagrant. On HCP Packer, it's the webhooks allowing you to integrate downstream and the enhanced metadata to really help manage the supply chain as we're building these images. Then on Terraform's core, it's provider defined functions to make the engine richer and more flexible. HCP Terraform coming to Europe now, having private VCS access with enhanced agents and policy enforcement as well. And then with things like the Explorer view, making it easier to manage a large-scale estate. HCP Waypoint bringing that internal developer platform to start abstracting away low-level infrastructure, and then hardening the runtime with Nomad and Consul. Right? So lots of great stuff. So maybe shifting gears now to the security side of things. Here we think about there's also a similar lifecycle. Obviously, you have to protect a set of credentials, secrets, data. You have to inspect where those things are being used. You have to connect to different secure infrastructures. And so how do we sort of think about that through that same lens of there's a day 0, day 1, day 2 lifecycle? Again, I think often people will think about the day 0 secret. I have to create a database secret and my app needs to read it. Great, that's obvious. You need it day 0. But then day 1, inevitably, you think about, well, how do I rotate that every 90 days or every 365 days? Your day 2 problem becomes, great, this thing was compromised. How do I do it? I need a run book that allows me to rotate it and redeploy all my applications in real time. Those become the sort of the life cycle challenges, right? So starting with Vault, I think one of the most common integration points for us is a Kubernetes environment. For most people, they started by using the Vault agent. That acts as sort of a sidecar to the pod, so it interfaces with Vault and then injects the secrets for the application. I think this has some challenges around sort of the duplicate nature of the agent. You have a lot of them, it takes up additional resources, and it makes the integration slightly more complex. So we introduced the Vault Secret Operator last year, which really simplifies this by having a native Kubernetes operator. That way, that single operator does the integration with Vault. It fetches all of the secrets and synchronizes them into the Kubernetes secrets. And then you don't need any additional agents or sidecars running within the pod. So some of the updates to the Vault Secret Operator are native OpenShift support, including its availability through the Operator Hub. Secret transformations, so this allows you to control how's the templating done when it reads it from Vault and then puts it on disk for the app, in case you need to put it in a specific config file format or specific place on disk for the application to understand. And then instant updates, which are coming soon. And how the instant updates work is over the last few releases of Vault, we've added a native eventing system. So this means anytime a secret is updated, anytime it's rotated, anytime it's revoked, Vault's publishing an event that clients can subscribe to basically react to that in real time. The Vault operator now uses that event stream to automatically listen and say, great, a secret was updated or revoked. It can fetch that and synchronize it and then trigger a rolling restart within Kubernetes. So now you don't have to do any polling or wait, for a time delay. The moment a secret's updated, we can automatically synchronize it and start restarting the application. So it just makes it that much easier to manage the life cycle of secrets inside of a Kubernetes environment. The next one is secret syncing. We introduced this as a concept at HashiConf last year, and now we're taking generally available the ability to sync into all 3 of the major clouds, Amazon, Azure, and Google. So what this allows you to do is define a secret within Vault, let's say a database credential, and then you can synchronize that into your Azure Key Vault, your Amazon Secret Manager, etc. So if you have existing applications that are already connecting to those systems, they indirectly can use Vault, and I can have one source of truth. So I don't have to change a credential in 10 different places. Right? At the same time, we're also adding support for more SaaS services like GitHub and Vercel. So a common use case ends up being that we're using GitHub Actions as part of our CI/CD pipeline. That might need credentials to things, but I don't want to have to manage it in multiple places. So I can store everything in Vault and then just synchronize into my GitHub pipeline. Another enhancement that we're bringing to Vault is what we're calling workload identity federation. So if we think about the classic way Vault would have managed something like, let's say, an Amazon credential, you'd give Vault something like a root IAM credential. So it'd have a very privileged key, and then it's using that key to then create sub-credentials for different applications. The challenge is that Vault has a highly privileged key in this case, right? That initial exchange requires providing often a root and static level credential, right? So now with this new integration with Workload Identity Federation, the way it works is Vault is generating a public and private key. The private key is used for signing of transactions, and only Vault keeps that private key. But we can share the public key with Amazon or Azure or Google and establish a trust relationship. So we can say, hey, if you see a request come that's signed by this public key, you can trust that that's coming from Vault, and you can use that to manage credentials. So now in this scenario, the only thing that we're sharing is this sort of public key. It's not particularly sensitive. We can share that easily. We can establish a trust relationship, and now Vault can create sub-credentials in a dynamic way without ever having static, long-lived root credentials, right? So it makes it a lot easier and more secure to manage these integrations. Now, if we think about sort of from a secret management best practice perspective, I think where we often talk about the sort of pyramid of maturity, right? At the top, it starts by how do I detect all the unmanaged secrets in my estate? How do I bring those into a common approach of vaulting and managing them somehow? But that tends to be a static credential. Over time, where I want to get to is an auto-rotated set of credentials, so that great, every 30 days or 90 days, I'm at least rotating those credentials. And then ultimately, I want to get to truly dynamic, short-lived credentials, right? So that the credential doesn't even exist until the client requests. The client gets a unique key, and that has a very short time to live, maybe 24 hours, right? And the reason that's so important is because even if we get everything vaulted, but there's long-lived and static, inevitably those credentials leak, right? The application logs it to Splunk. The user pastes it into Jira. And so the longer a credential lives, the less secret it is. So the further we can get down to they're short-lived, they're unique, they're just in time, we don't have to worry about those credentials accidentally leaking and then years later getting compromised. So one of the areas that we're sort of enhancing is around thinking about the rotation, right? So last year we introduced HCP Vault Secrets. It's our cloud-native version of Vault, so multi-tenant built into HCP. You don't have to think about clusters or scaling. And so one of the features we're bringing to that now is auto-rotation. So this allows you to set up a schedule. So you can say I have a Mongo credential, for example. I want to auto-rotate it every 2 weeks. And what Vault will do is maintain multiple parallel versions. So you might have version 1 that lives for 2 weeks, and then version 2 will exist sometime with an overlap. So as applications come in, they can get the newest version, and then over time, Vault is cleaning up and automatically revoking the old versions behind it. So this starts to let us move from sort of those static credentials into those auto-rotated credentials. Now, at the same time, we have a similar challenge that exists around certificates, right? Oftentimes, we see people with very long-lived, PKI certificates, maybe 1 year, 5 years, 10 years at a time, because the process of generating and rotating them is difficult. So there's a number of standards that are being created to sort of simplify that automatic generation rotation enrollment process. One of them is what's called enrollment over secure transport, or EST, and it defines a process of how does an application authenticate, how does it generate a request, how does it get signed, how does it ultimately install that cert, and then how does it get rotated. So it's about managing that entire life cycle of a certificate, not just the initial generation of it. And so now we've added support for certificate automation into Vault as well. So using this protocol makes it a lot easier to integrate with systems and have a fully automated lifecycle around how those certs are built and managed. And this is a common protocol used in IoT systems, various endpoints, and now more commonly in applications. Now, one of the things I mentioned earlier with Nomad and Consul was this notion of a long-term support release, right? I think when we think about systems like Vault, Nomad, Consul, these are kind of critical tier 1 systems. Oftentimes, they're running across tens of thousands of machines in complex production environments. So the idea of having to do a frequent update that impacts 10,000 machines isn't always fun. And so I think one of the challenges, for customers, and we've frequently heard, is HashiCorp updates the software a lot, which is great. We get new features, we get new capabilities. That's the great part. The bad part is it's sometimes hard to stay up to date with us, right? Especially in these large production environments. And so with the introduction of long-term support releases, this gets a lot easier. Now what we're doing is basically saying once a year, we will have a release that's supported for up to 2 years at a time. So if you're running an LTS version, we'll backport security fixes and bug fixes and hardening into those things, and we'll give you an upgrade path that lets you skip over all of the intermediate updates to go directly to the next long-term support release, right? So with the latest versions of Vault, Enterprise, Consul, and Nomad, all of them now have an LTS release. Once a year, they'll have one. That allows you to kind of skip over the next 2 major versions if you so choose. Now, if you want the latest and greatest features, great. You can always upgrade. There's no reason you can't go to those other versions. But in an environment where you value more of the sort of stability and operational sort of overhead of doing these upgrades, this is a great option. So now I want to just sort of showcase what some of these features actually look like. So starting off with the HCP Vault auto rotation, what does that actually look like? So great, we're going to go into HCP Vault secrets here. Within the application, you can see we've already configured MongoDB. So if we click in, we'll see we currently have a single version. There's only one credential, and it's going to auto-rotate in some period of time. Now we can come in and force it, maybe because we suspect a compromise or something else, or we just don't want to wait 2 weeks for a demo, right? So we can go in, force a rotation, and now if we click in, we can see there's actually now 2 versions active, right? Version 1 is still active, and now version 2 is there as well, right? So you can see there's an updated credential. Now, if we log into Mongo's portal, we can do a refresh here and see basically that great, we've automatically connected, we've generated this new set of credential, we haven't yet revoked the old one, right? So you can start to see how this starts to simplify that lifecycle. We can integrate with various systems and basically generate and do that rotation automatically. And eventually, if we wait long enough, we would go back and delete that credential as well. So that full life cycle of creation and management and deletion gets managed by Vault. Now that connects directly with the syncing capability. So let's say the same application, we're using systems like GitHub or Azure. Here we've set up a sync to Azure Key Vault as well as GitHub Actions. So all of the credentials that are for this app are being synchronized out. So if we go to GitHub, we can see the Mongo credentials here. It was updated 35 minutes ago. We now refresh the page and we can see, great, it just got updated 3 minutes ago. So the latest version of the credential was automatically synchronized. When we did that rotation, it pushed it, and now our developer doesn't have to think about it. They're doing their build within GitHub Actions or running a various sort of a trigger. They don't have to think about the credential management of that. It's all done in one place. So now when we sort of think about the top levels here with sort of the vaulting and the unmanaged side of things, one of the biggest problems we end up seeing is even if we perfectly vault all of the credentials, invariably what happens is the application logs it to Splunk, a user pulls it out and creates a Jira ticket and puts the Amazon credential in there. And so we bought a company last year called Blue Bracket and introduced it as HCP Vault Radar. And the idea of Vault Radar is that you can connect to all the places where we actually do work, whether it's Bitbucket, GitLab, GitHub, Azure DevOps, etc. And now we're expanding that with support for Jira and Confluence as well. So the idea is anywhere that our developers are really working, and over time this will include Slack and Teams and other systems as well, is that we want to be able to scan those things because invariably what happens is your weakest link is probably not Vault. It's somewhere in between the chair and keyboard, right? And so, how do we actually find that those secrets got leaked? So what does that actually look like? Great. In this case, we're going to configure it to say, we want to scan Confluent. Oh, sorry, I'm skipping ahead here. The other piece here that's important is our ability to correlate secrets to things that we find in Vault. So one of the hard problems with a lot of these tools is they have a high set of false positives. They look at a thing and they say it might be a secret, but we don't really know. One way to really know that it is a secret if it matches something that is already in Vault, right? If the credential is in Vault and it's a perfect match, it's a pretty good chance it's a valid secret that's still active. So this is a feature we're calling Vault correlation. Basically, Radar can connect to your Vault and basically build an index of the secrets so it knows what's actually stored in Vault currently and historically, and it can use that to match to the credentials it finds. So if we see a match to an existing credential, we can tell you, hey, this is the location. We see the same key in Vault, but we found it sitting in GitHub. This is a high-value credential. You probably want to go take care of it, right? So what does it actually look like, right? So when we talked about these new sources, so if we go into Radar, in this case, we're going to filter it down by just looking at Confluent, right? So somebody might have just published, for example, a new runbook that said, hey, if you're having an outage, here's how you run the recovery play, etc. And so we can see, great, we've detected a credential within that. We can click through into the actual Confluent page. And if we scroll down, we see, great, here's the credential that the user pasted in as part of that, right? I'm sure none of us have ever seen this happen. And so this makes it a lot easier as we start thinking about, great, there's a continuous process of we have to first move all the credentials into a vaulting solution, but then we have to constantly scan to make sure that we're not leaking these things as well. And over time, this is one of the motivations to move away from static secrets into dynamic secrets entirely, is so that this credential hopefully isn't valid 6 months, a year, 5 years from now if an attacker finds it. Now, the other side of this is how do you actually broker access between our human users and the applications in an environment? Historically, this was done with things like traditional VPNs. A user can VPN in and they're on the production network, or you had SSH bastion hosts where you had the one SSH key that could access everything in the environment. I think the challenge with those things then it becomes a bunch of how do I actually segment access to least privilege, right? You really only need access to just one Kubernetes cluster, but now you're on my production network with access to everything, right? Or how do I know what did the user actually do when they were in that environment? Or the user left the company and they took that SSH key with them and it's used on 1,000 machines, right? And so how do we move away from that? What we really want is just-in-time access that's identity-based, that's limited to only the systems you need access to. So really a least privileged, zero-trust model. So what Boundary does is really tightly integrate into your identity provider. It might be Okta, Azure AD, something else. So it's an identity-based integration. You don't have an SSH key. You don't have a username and password for it. So if you leave the company and you can't sign in anymore, you can't take anything with you, right? Then it's about brokering a secure connection only to the systems you have privileged access to. So unlike something like a VPN, which puts you on the network, Boundary is more of a reverse proxy that's identity aware. You only get access to the systems you're granted, right? And then I don't necessarily want you to ever see the keys, so we can integrate with Vault to do dynamic secret injection, right? So if it's a database or an SSH key, we can dynamically fetch an SSH key from Vault, use that to connect to the session, and the user never sees the SSH key. And at the end of the session, we can revoke the database credential or revoke the SSH key, right? So that way it becomes just in time, it becomes least privilege, and it's sort of a zero trust approach to accessing our network resources. So a bunch of key updates in the Boundary space, right? One of them is enhancing the governance around some of the session recording. So a lot of regulated business, you have to keep the recording for at least N number of years. You might want to have it visible for a year, but you have an archive for 7 years, things like that. So a bunch of improvements around that lifecycle management. The other one is how do you make it simpler for the end users by having aliases so they don't have to remember target IDs or arbitrary identifiers, so they can have easy to use phrases to connect things. And then searching and filtering and making discovery easier if you have a large estate where you have many thousands of resources and sessions, it can be hard to navigate. So making that easier with search and filter. So what does that actually look like, right? So showcasing some of these improvements. So if we're logging into the Boundary UI, first thing we might want to do is establish a session, and so we can see these convenient aliases. So in this case, we're just using my Linux host as the alias. We don't actually have to know what's the ID behind that. Makes it a lot easier from the end user perspective. Two is if we have lots of different sessions within our environment, there's now enhanced searching and filtering, so we can filter down by state, filter by the target, and quickly figure out, okay, this is the session for that particular user. Makes it easier to manage in a large-scale environment. And then on the session recordings themselves, if we click into a recording, we can now see that we have automatic retention and deletion policies, right? So we might say retain it for a certain period of time, auto-delete it after a certain period of time. Makes it a lot easier so you don't have to manually manage the archival and deletion of these things, right? So pulling out and sort of summarizing some of these, again, with HCP Vault Secrets, bringing secret sync capability to major cloud providers, auto rotation into the cloud native HCP Vault Secrets. For Vault Enterprise, secret sync coming there as well. The workload identity federation and the certificate automation through EST. And then with the Vault Secret Operator, OpenShift support, transformations, and instant updates. For Radar, it's the update to bring in Confluent and Jira, as well as the correlation to secrets that we detect in Vault. And then with Boundary, it's the enhancements around session recording and user-facing workflows to make it easier. Right? So zooming back out, again, the goal, and we sort of, ending in some sense where we started, is as we think about that platform with the HCP experience, it's really focusing on saying, how do we make that lifecycle management easier, the security pieces easier, and drive that correlation? So you can see with like Vault and Radar as an example, really bringing those together, say, great, if you're storing it in Vault, we know about it, we can correlate to what we detected. It makes it that much easier by having that integrated workflow. With some of the Packer and Terraform pieces that we saw, it's about the image management of the lifecycle. With things like Waypoint and Terraform, it's about abstraction of the developers. So with all of these things, we're trying to bring these different pieces together, be a little bit more opinion about what does that day one, day two workflow look like to make it a lot easier. So now I want to kind of bring this to life by having a customer share their journey and their story about making this true for their organization. So please join me in welcoming Stefan Wagner from Lufthansa Systems.
Hi, Armon.
Thank you so much, Stefan.
Thanks for having me. So many new announcements you have.
I know, exactly. I'm amazed we're on time here on the keynote at all.
Very good.
Well, thanks so much for joining. I think most people are probably familiar with Lufthansa. Half of us probably flew in on Lufthansa. But maybe give us a brief sense of what does Lufthansa Systems do? I know it's part of the larger group. And then what's your role at Lufthansa Systems as well?
Yeah, happy. Thanks, first of all, to have me. I hope you guys had a good flight in. I hope many from you took Lufthansa to get here to Munich. I hope everything was punctual. If not, it was not an IT outage. Any chance?
Blame Boeing. The doors are falling off. Yeah.
Right. Anyway, so Lufthansa Systems basically is a 100% subsidiary of the Lufthansa Group. Lufthansa Group obviously is a large conglomerate out of many airlines. You have Lufthansa Airlines, you have Swiss Airlines, Austrian, and many more. And we are basically the responsible entity for IT things within the group. We have a large community with more other colleagues working on, but primarily we are, I would say, the biggest one. So on the one hand side, we support Lufthansa and their airlines with their IT demands, the classic things, I would say. On the other hand side, we're very, let's say, busy with our product portfolio. So Lufthansa Systems actually has around, I think, 25 different products on the market, which are in use within the Lufthansa Airlines. But we are also selling this on the external airline market and running this on our cloud platform for around 350 other airlines. So they're utilizing us. One of the examples that you guys may be aware of, if you fly intercontinental and you have the entertainment system, like that puppy basically comes from us. And the other thing, I always explain this, the pilot also has to know where he's flying to, so he doesn't know it, obviously. So we have a product called Lido Flight, which is kind of the Google Maps for the pilot, actually. So there's a lot of products that are very intransparent. You don't see them as an end user, but they are working in the background to basically support the full processes. So that's what Lufthansa Systems is around. We are headquartered in Frankfurt, obviously, where Lufthansa is headquartered, and we have around 3,500 employees.
Awesome. And maybe just share briefly on your role as well.
Oh, yeah, sure. Sorry. Yeah, so I'm Stefan. Basically, my unit is responsible for the everything that has to do with, let's say, technology enablement. The biggest part that we do is to develop and operate our internal cloud platform, which we call the Global Aviation Cloud. So particularly are built for airlines, so high demands for certifications and security in that sense. And it's built on top of public cloud, so we're leveraging their various providers. And basically automate everything from the deployment perspective where our customers then can consume it in that sense. So we're engineering that, we're operating that 24/7 with the full cloud operations, and that's what I'm responsible for.
Great. Well, I know it's been a bit of a journey as you've gone to cloud. Maybe just rewind the clock a little bit and give us a sense of sort of what was the start point as you went back to sort of private data center and sort of where the origins of some of these systems were. Obviously, you guys have been delivering the services as long as the planes have been flying, and that's been before cloud. So maybe just give us a sense of how it's evolved.
Yeah, that's true. That's true. I mean, both of us probably adding up our ages, Lufthansa is older than that. So we do have a quite old IT in that sense. Historically speaking, we were operating out of data centers in the Frankfurt region, managed in-house. That has been changed in 2015. There was some outsourcing program done basically where IBM took over. So funny here, like roads cross again.
Back in the family.
Right. So that's kind of what is managed currently by IBM as a partner. And basically in that time, all of our applications were running in that data center. Then we quickly basically realized we need some additional landing zones because our customers, they're not only located in Germany, we have them in North America, South America, we have them in the APAC region, and we need something to actually bring the applications close to them. So that was the time back then in 2016, 17 roundish, where we already started building our initial version beta or something of our global aviation cloud within Microsoft Azure and, going from there.
And then I know you guys generally have like a multi-vendor strategy, certainly at everything from high-end hardware like the planes. How did that translate into sort of a multi-vendor strategy around cloud?
Yeah. Looking again shortly back in time, the technical evolution is like a classic lift and shift that we did. So we started out mostly moving our applications just from a data center into Microsoft Azure primarily. And there was a lot of things to do. So we were busy a lot moving our applications to be cloud compatible. So we are right now in a state where some of the stuff is like maybe cloud native, utilizing more SaaS and PaaS services, but there's a huge chunk which still relies on classic compute. So we have thousands of VMs and compute basically on Azure. And now over time, realizing that public cloud, it's easy accessible, but it has its fault in regards to reliability. Of course, you get your SLAs and you get your credits when something doesn't work. But for an airline, basically, it means if it doesn't work, then the planes are not flying, right? So, and there's a certain security risk as well for stuff that is in flight. So we quickly realized that in, I think, three years ago, something, when we had most of the stuff migrated in, that we not only need like a multi-regional strategy with disaster recovery, but for the really critical things, I mentioned lead of flight, like if that thing doesn't work for like 15 minutes, like an airline doesn't operate. And then you have the problem in the following days with the schedule and so on. So that's the time when we basically decided to introduce Google Cloud as a secondary provider following our multi-vendor strategy. And since then, our customers can choose to run in either of those clouds or in a combination. So we have specific large airline groups who are actually utilizing our products in both clouds in an active passive way with a specific RTO. And that's what we are running as of today in like 12, 13 regions as part of the global aviation cloud.
Got it. And I know you mentioned sort of the start point was very much traditional private data center, ticket-driven ITIL. What was the sort of introduction point for things like Terraform to come in to start to bring in more automation into that?
Terraform was there before my time when I joined back then in 2018, and I actually checked it for our short talk. So I think, started out with Terraform 0.9 or 0.10, something like that.
Early days, yeah.
Without loops and those kind of things, so very early. And we went through the open source kind of thing, right? So we started out having tons of Jenkins instances in all of our different regions, having to manage all the states and Azure blobs and so on. So that's kind of where we came from that perspective. And basically, it enabled us for writing templates for our application migrations. So, right, one of our biggest tasks was to move all that load from 6,000 servers or something into cloud. And our environments are mostly repetitive. So our customers, they have similar environments, maybe different sizing, and we utilize Terraform to build those environments for our different products to then easily spin it up, migrate the data over, do a cut over, and then basically move in the cloud basically live. So this is like from Terraform perspective. And now over time, basically, we found out that it's just a huge amount to manage. Like you have to manage all the Jenkins plugins, all the versions. You have to, check, oh, damn, you forgot a pipeline. It's still running on 0.12 or something. And now, meanwhile, you're at 1.8. So it's like you don't have that central overview. Yeah, exactly. So
maybe just sort of share a little bit about that journey then to the commercial product, because I know it sounds like you guys kind of went through that classic adoption of open source, sort of use that to drive the migration, then start to run into these challenges. What was that sort of transition into the commercial product?
Yeah, so from the open source world, we basically, I think 4 years ago, something like that, we started to see what else is out there from option perspective. I think many of your customers maybe went the way with hosting Terraform on your own. We have a larger estate with servers, but we actually try to keep it down as much as possible. And obviously that runs only on Red Hat Enterprise Linux, so we don't want that primarily. And that's when we decided actually to move straight into Terraform Cloud for Business back then. Basically moving all of our different templates and pipelines over there. We have not completed that yet, so it's still like an ongoing process because we're still busy with migrations, I can tell. So we straight went to Terraform Cloud, and this is what we primarily use of today. Yeah.
Got it. And so then I know one of the things we were talking about before was sort of the kind of the metrics of success, how you sort of measure it. Maybe just share a little bit how you think about that and how it sort of changed a little bit of sort of size and shape and dynamics of the team as you've sort of brought in more automation and went sort of to the cloud product where you don't have the overhead of managing the pipelines.
Yeah, sure. So I think best to answer that is with some metrics in the end. So back in time when Lufthansa Systems was still operating those data centers, we had, I think, around 450 colleagues managing data center operations, IT operations. My team today with cloud operations and also engineering is around 100 people. So it's kind of a fourth in size, doing the same thing, if not even more, because we have in those years additional customers moving from on-prem, so to say. So we actually have less people. They have a different focus in their work. So now they focus more on optimizing the deployments versus taking care of the infrastructure in the end. And so this is, I think, the most essential part that gives us the benefits. Yeah? And so they can now focus on optimize the infrastructure, give our development teams the option to self-service infrastructure. So we have we're building like a developer portal at the moment where they can consume all the infrastructure services, the database, and manage VM and so on from our teams, and they don't have to work with tickets anymore. So of course, we started out with ITIL. We have those Jira and Service Desk and don't ask me what things, and we still have that, right? And we still need that for certain things, but really for the commodity things, we don't want to go there, and that's not what I want to keep my guys busy with.
So I think there's sort of clear benefit, I think, in terms of sort of the size and scale of how much a smaller team is able to manage. I guess the flip side, and I'm curious, is like what the metrics in terms of like agility of those teams, right? Like how long it used to take to provision environments versus how long now it takes them to kind of manage, even though they're managing even more environments.
Yeah. So in early times when we started out with cloud, like before Terraform, I'd say that a typical customer project or cutover took like half a year.
Yeah.
Maybe a little bit longer, depending on the size of the airline. And building the infrastructure was obviously a manual task. Maybe you even had to order servers and so on, had to bring them to the racks online. Meanwhile, we optimized it that way that the infrastructure provisioning is down to like 1 or 2 days maximum because we have those templates. The application teams mostly do it themselves. And I would say that in a total of 4 weeks, we can actually from contract signature to go live, it's around 4 weeks. Why there is more weeks? It's not because of the infrastructure. It's because of airlines have, I can tell you, tons of interfaces here, MQs and APIs here. They have to get whitelisted, private peering. So it's like more the integration part that now takes time. But like our part is like really down from months to like a couple of days.
Which is huge, yeah. So it's both just the efficiency of it, but also the speed and agility that the business has. Yeah. So I know you said it's a multi-year journey for some of these applications, but you said you're now in the final phase, the scream phase of the migration. Maybe share a little bit more when you say the scream phase. What do you mean by that?
Yeah, it's exactly what it's called like. So what we are now in the phase in our multi-year migration project. Our target is to shut down our data centers in December this year, because actually the buildings have been sold. They will be run for something else starting in January. So we actually have to move out. We've done a lot. We've run tons of network sniffers to actually see what is the remaining pieces of hardware doing, because, over the 20, 30 years, we just don't know anymore. There's like stuff in there. Nobody knows. People have gone. Nobody knows what's running in there, right? So we don't know, right? And the scream phase is like, we literally pull the network plug and see who screams. And then if somebody screams, we pull it in again, right? And then see how we can migrate it. So
if the plane doesn't land, then plug it back in. Yeah.
So those critical systems we have migrated. So it's like hopefully only smaller stuff. But yeah.
That's awesome. Well, wishing you luck on the December deadline. So maybe sort of kind of wrapping us up here. I know we spent a lot of time talking about Terraform. Obviously you guys have driven a huge level of maturity from where you sort of started a few years ago. How do you think about sort of what's next, right? When you think about what's next for your, where are you taking HashiCorp? Where are you taking sort of the cloud platform? Curious on your view.
So we've been with HashiCorp for as long as I've been with Lufthansa, even before I've used HashiCorp products. So I'm foreseeing there is still like a lot of things going on. Right now we are focused with the cloud migrations a lot. So what I want to do is like still clean up the things that we have, get it into Terraform Cloud. Obviously, one of the next things I'm very stoked about, making all of our data protection guys happy, is the EU version of Terraform Cloud, something we've been discussing since 4 or 5 years, if I'm not mistaken. So this is something ongoing, like to clean up, to really centralize everything to one common platform layer that has been built over the years. And the very second thing we didn't talk about that is the vault part. So this is like the second big thing that we are actually utilizing since quite some time. Starting out with extracting secrets from the classic Jenkins things, and then at least moving it into Vault to secure the pipelines a little bit better. But here we have a decentral deployment, so we have a lot of vaults. Our people are busy with operating then on top of Kubernetes in our 12, 13 regions. So this is going to be one of the next big projects to actually reiterate over the HCP Vault thing, which we actually have been a launching customer back then in time. I remember that. But honestly speaking, we have never really brought that into production due to the missing Azure functionality. So this is like the next thing, seeing that we can basically ramp up HCP Vault and then do the same thing basically that we did with Terraform open source to move it into a common place, put ease to our operations team on the security side, and give you basically the empowerment to do the things. The same thing as we request from our customers.
Really moving to almost the same platform-based approach versus this distributed approach. So it's almost same journey. Awesome. Well, thank you so much, Stefan, for joining us and sharing your story. This was awesome. Thank you. Really appreciate it.
Thank you. Thanks for having me.
Okay. Awesome. That was a great story, and thanks so much. Really appreciate it. Always better when it comes from a customer than from us. So maybe just to kind of wrap us up here, I think hopefully what you're sort of seeing is sort of this continued focus from us on really trying to bring these different pieces of the portfolio together, big focus on both the infrastructure and security lifecycle management pieces, and over time bring more maturity and depth of capability to each of these tools, but also making them easier to use, more prescriptive, more tightly integrated. What you're going to see is a lot more of a deep dive into all of that the rest of today. So if you're staying in this room, this will be the cloud engineering track. We're going to go deeper into both the ILM and SLM new features and capabilities that we talked about today. If you're in the other room with the leadership track, we're going to go deeper into some other organizations who are going to share more similar to Lufthansa about their journey, their process, some of their learnings as they've gone through it, some of the ways we're working on sort of helping be more prescriptive through things like HashiCorp validated design, some of the work we're doing with our partners, many of whom are here. And then things like maturity models to help you assess where you are on the journey and sort of our recommendations on what we think are the next steps based on our experience working with other enterprises. So with that, I'm going to hand it back to our MC, Bruno, and hope you all enjoy the day. Thank you so much for joining us.